Okay, so you had the task of completing this contingency table and then answering probability questions. So the first thing that you should have done was, of course, read the problem. And after reading the problem, you should have been trying to locate the different sets of characteristics. So we have two defining sets of characteristics. We have marital status, and then we also have the smoking habits. So marital status, we either had people who were married, and I'm just going to call them M's, and then we had people who were divorced, and I'm just going to call them D's, and then we had people who were not married or never been married before, and so I'll call them N's. And then we had smokers, and I'm going to call them S's, and then we had not smokers, and I'm going to call them S bars. So now it said a study of consumer smoking habits includes 200 married people. So 200 married people, that tells me about the subtotal for married. And 54 of those smoked. So married smokers, there were 54 of those. Then the next one says 100 divorced people, so 100 divorced people here, and 38 of those smoked, so 38 of those smoke. And then the never been married people, there were 50 never been married people, and it said 11 of those smoked. So now we have these filled in, and I'm going to rewrite this a little bit better. Now we can go ahead and we can start going for the other totals here. So we need subtotals. Well, the first subtotal that'll be the easiest to find would either be the total for smokers or the total grand total. So I think grand total is probably easiest. 200 plus 100 plus 50, that's 350. Now this one, 54 plus 38 plus 11, so we have 12, so that'd be 92 and 103 for that one. And then the next one here, we would have to do a subtraction, 350 minus 103, so that would be a 7, and let's see, 4, and that would be a 247, I believe. Let's add it up and make sure. 0, carry the 1, 5, carry the 1, no, that would be 4, so this would be only 147. Pardon my subtraction error there. Wasn't paying close enough attention. So is that true? No, wait a minute. 0 is 1 is 5. No, that was right. I was right in the first place. 247. All right, now let's go through here and make these subtractions. 50 minus 11, which would be 39. So that would be 0, carry the 1 is 50, yes. 100 minus 38, so that would be 62. And then 200 minus 54, that would be 1 and 46. And then let's get out a calculator here and just make sure everything's right. So 146. Then plus 62, and then plus 39, and that's 247, so that's a check. 54 plus 146, that's 200, so that's a check. So let's see, can't see the upper one there because of this thing being in the way. Let's see if I can move this. There we go. Let's see, we have 38. Oops. 38, and then plus 62, and that's 111, oops, plus 39, and that's 50, and 103, plus 247, and that's equal to 350, and it looks like I have everything added up, and so I'm happy with that. So indeed, I think I have all my things correct, and I have a contingency or a two-way table. So now, once I have the two-way table, I'm asked for the probability that a randomly chosen person is a smoker or is divorced. So this says the probability that this randomly chosen person is a divorced or a smoker. So that's what I'm going to have here. And therefore, I'm going to have the probability that they're divorced plus the probability that they're a smoker, And because this is a two-way table, I know there's going to be interference between being smoker and being divorced because there's people that can be in both of those classifications since how they're two different classifications on the same set of people, so smoker and divorced. And remember, it doesn't matter what order we put any of these things in, it's still going to give us the same numbers. So the probability of being divorced, well, there were 100 divorced people out of 350 people. So 100 out of 350. And then plus the smokers, that's 103 smokers out of the 350 people. And then we've got to subtract out the people that we counted when we added all these up and that we added all these up. And that would be the 38 out of 350 that were both divorced and smokers. And so that's what we have there. So now we have a total here, and that's 203 minus 38. So 203 minus 38, and that's going to give us 165. So 165 out of 350. Now we could certainly reduce that, right? I know it reduces at least by 5s, but I'm just going to go ahead and give it as a decimal. So approximately, so 165 and then divided by 350, and that's going to give us 0.471429, 0.4714, what did I say, 429. And remember, I like to give them out to 6 decimals and then round appropriately so you can really see where I'm rounding. And remember, the correct round off is to that decimal place right there, 471. And that would be what I would report, is the probability is 0.471 approximately. Remembering that these two symbols, the equal sign with a dot over it or the squiggly equal sign, those both mean approximately, and I can use them 100% equivalently. And then the last one is asking for the probability that it's single or does not smoke. So this is the probability that they're single, so never been married, or that they do not smoke. So this one's just going to look like the probability that they've never been married plus the probability that they don't smoke, and then we have to subtract out the probability that they've never been married and they don't smoke because there is an overlap there. So the probability that they've never been married, there's 50 out of the 350 that have never been married, so that's 50 out of 350. And then the probability that they're not a smoker, so not smokers, those would be 247 not smokers. And then to top it off, we've double counted those that are not smokers and never been married, never been married and not smokers. So these guys and these guys had an overlap here of 39. So 39 out of 350 have both sets of characteristics that we counted twice. So we'll subtract these out here. So we have 50 plus 247 plus, minus the 39 of overlap. And that gives us 258. So that's 258 out of the 350. And then once we have that, then we'll give it as a decimal approximation. So that's divided by the 350. And that gives us 0.737143. 737, what did I say? 737143. 737143 approximately. And that means that I'll be rounding this off to right here. And this is not a 5 or higher, so this is approximately 0.737. And again, I like to give you extra decimals out here so you can see kind of what I'm doing. I'm not just cutting it off at the place it needs to be. So that's the probability that we were looking at. Now the next thing I want to show us is a relative frequency table or a frequency table and how we can find probabilities based upon that. So what I have here is a frequency table that describes telephone call data and the number of minutes. Now remember, in our frequency tables each of the classes are mutually exclusive. So if I have telephone call data being given in minutes, there are no seconds. In other words, you're either on the phone 1 minute, 2 minutes, 3 minutes, 4 minutes. So if you're on seconds, it's rounding it up or rounding it down appropriately. So if we have 0 to 3 minutes, then you're certainly not on the phone 4 to 7 minutes, etc., etc. So if I wanted the probability of being between 0 and 3, and the probability of being between 0 and 7, the probability of being between 0 and 7 is the probability of 0 to 3 plus the probability of 4 to 7, because these are disjoint events. They're mutually exclusive from one another. And this is a nice thing to look at because that's not what we were seeing in the two-way tables. So we can compare and contrast ideas where we have mutually exclusive events versus not mutually exclusive events. So let's see if I can get this question on here. We have, what's the probability that a randomly chosen person would be on the phone less than 4 minutes? Well, being on the phone less than 4 minutes, let's see, I'm going to put this in reds just as a dividing line here so we can see that we have different problem going on. So this is the probability that our phone call, now we could say that random variable x is less than 4 minutes, right? And define x, our random variable, is equal to the number of minutes on the phone. And that, you see, starts getting into probability notation that just doesn't have some variables in there, but it actually starts to look like a math problem. So this probability of being less than 4 minutes, well, that's the probability of being on the phone 0 to 3 minutes. And this idea of mutually exclusive, that is the less than, strictly less than, where we have mutually exclusive. That means that we're having everything that's below that, and that's actually something that's really important when we get to binomial probabilities. So the probability that we have 0 to 3 is 3 out of all of the 49 calls that we had. And then of course we change this to a decimal, and I'm gonna, in the essence of time here, not give all the decimals, and I'm just going to write it as we need it to be 0.06, and I think it said 19, no, 12, like that, and that's the probability that I would give. Now let's go down to the next one, and the next one says the probability that they're on the phone less than 12 minutes or more than 39. So x is less than 12 minutes, or x is no more than 39. So no more than 39 is less than or equal to 39. Now it's really important that, oops, sorry, I read the part C. That one actually is more than 39. So we're going to go for more than 39. So part B, less than 12 or more than 39. Now it's really important that we do have the correct notation here, because you notice that 39 is in this class. So if we included 39 and above, we couldn't really get the probability because we don't know where this 1 comes from. You got to really watch that in terms of things that are mutually exclusive. You have to make sure you're getting the correct things. So this, because we do have disjoint events, is really the probability of being less than 12 plus the probability of being greater than 39. Now there's a couple of ways to look at this, and we can look at this as just adding all of these up, which is actually then the probability of 0 to 3 plus 4 to 7 plus 8 to 11, and then plus the probability of being 40 to 43, 44 to 47, and 48 to 51. So why don't you try to figure out the rest of the probabilities, and I will come back in another video and briefly go over those.